Hello kids, welcome to my channel, Hi with Himani. Today we learn the divisibility rules of numbers. In this video, I will tell you the divisibility rules of 2, 4, 6, 8, 7 and many other numbers. But along with that, I will also tell you the trick of finding out the divisibility rules of many bigger numbers. So be with me. So let's start. The first divisibility rule that we will do is the divisibility rule of 2. What does it say? If the unit digit of any number is 0, 2, 4, 6 or 8, the number is divided by 2. In other words, we can say if the number is an even number, the number is divisible by 2. Like for example, if the number is 56, the unit place has 6 on it, then that means it is divisible by 2. It is an even number. Then also we can say it is divisible by 2. But 57 or 55 is not divisible by 2 because these are not even numbers, nor do they contain the digits 0, 2, 4, 6, 8 on their units place. So I am quite sure that most of you must be knowing the divisibility rule of 2. The divisibility rule of 3 is very interesting. It simply says that you have to add the digits of the number and the sum which comes. If it is divisible by 3, we can say the number is also divisible by 3. Shall we understand the same thing with the example? Suppose if we have a number like 768. If what we have to do, we have to check for 3. So we will add these numbers 7 plus 6 plus 8. That will come out to be 21. 21 is divisible by 3. We can say yes, the number is divisible by 3. Suppose instead of 8 over here, we had 769. In that case, the sum would have been 7 plus 6 plus 9. There is no need for this equal to. Okay. So 7 plus 6 plus 9. This will be equal to 22. This 22 is not equal to 3, is not divisible by 3. Therefore, we would say that 22 is not divisible by 3. Simple. So, divisibility of 4. In this, we have to see that if the tens and the units place of a number, they together are divisible by 4, then the entire number will be divisible by 4. So can we learn it through an example? Suppose the number is like this, 1564. We just have to check the tens and the units place to check the divisibility rule of 4. We are not concerned with this number at all, whatever this number is. We just have to check the tens and the units. Number is 64. 16 fours are 64. 64 is divisible by 4. Therefore, I'll say the entire number 1564 is divisible by 4. Simple. Now, we'll talk about the divisibility rule of 5. I'm sure you must already be knowing about this. This is very simple. If the number unit place has 5 or if the units place has 0, the number is divisible by 5. The numbers like 15, 10, 1565, whatever. We just have to check the units place. If it is 5 or 0, we know that the number is divisible by 5. Then the divisibility rule of 6. 6, as you can see, it is made up of these two numbers, 3 into 2. 3 into 2 is 6. If the number is divisible by 3 and is also divisible by 2, we will say the number is divided by 6. For example, or on another words, we can also say an even number which is divisible by 3 will be divisible by 6 as well, because even number will be divisible by 2. And then if it is divisible by 3, both the rules, are qualified here. So, for example, the number is 1, 5, 6 and 3. If this is the number, this number, if we add the digits, 1 plus 5 plus 6 plus 3. So, this 9, 10, 15. This number, 15 is divisible by 3. But since it is not an even number, it is not divisible by 6. But if it would have been like this, 1, 5, 6, 0. Now, if we add this will become 12. And here it is an even number, 1560 is an even number. Then this number will be divisible by 6. This number 15 will not be divisible by 6 because it was not an even number. So for 6, it is very simple. We have to check that whether the number is divisible by 3 and as well as 2. If both these properties are, the number qualifies for both these qualities, then the number is divisible by 6. Now we'll talk about the divisibility rule of 7. In many books, they have not given the divisibility rule of 7 because many students find it quite typical and they find it, to actually divide the number and to check, simply without using this rule. But it is all up to the student. But I will tell you, because as a student, you should know what is the divisibility. Then it is up to you whether to use it or not. But as a student, you should know what is the rule for the divisibility of 7. So let's take this number 762. I'll start with the example only. So what this is that take the unit number first. Take the unit number, double the number. After doubling, we get 4. And what I have to do is, whatever the remaining number, I have to subtract this 4 from the remaining number. And the number, whatever I'll get, I just have to check for it. Sorry, it's 72. 76 minus 4 is 72. I have to check whether this number is divisible by 7 or not. Since 72 is not divisible by 7, I will say that the entire number, this is not divisible by, this is divisible by 7, no. So therefore, 762 will also not be divisible by 7. Let's repeat this entire thing again. What is the divisibility rule of 7? I'll repeat this again. What I was doing here is, I was just taking this units number, doubling the units number, and subtracting it from the remaining number. Whatever number I get after subtraction, I just have to check for this number whether this number is divisible by 7 or not. Simple. Now we know that 72 is not divisible by 7. Therefore, 762 will also not be divisible by 7. The divisibility rule of 8. In this, what I'll do is, I have to check the hundreds place, the tens place, and the units place. If the number is these 3 digits together, whatever number they form together, if that is divisible by 8, then whatever number it is, we don't have to bother about that. We just have to check the divisibility for these 3 places. For example, if I have this number 15632, I don't have to bother about this thing at all. I just have to check whether 632 is getting divided by 8 or not. I'll check it, and since I'm telling you that yes, it is divisible by 8, then the entire number 15632, that is 15,632, will be divisible by 8. So for 8, we are checking the last 3 digits. 632 is divisible by 8 completely. 8 sevens are 56. If you want, you can do it together. 8 sevens are 56. So 56 and 8 nines are 72. So it's this, completely divided by this. So if 632 is divided by 8, then the entire number 15,632 is also divisible by 8. Simple. Now 9. 9 is the same like 3, but here the difference is, in 3 what we were doing, we were adding all the digits and we were checking the sum, whether the sum is divisible by 3 or not. Here also we will add the digits of the number and we will check the sum, whether the sum is divisible by 9 or not. So let's take any number, 5, 6, 4 and 3. If I add this, 5 plus 6 plus 4 plus 3, that will give me 18. 18 is divisible by 9. Therefore, this entire number will also be divisible by 9. Simple. Now, shall I tell you this divisibility rule of 10? You must be knowing, right? Just for the sake of telling you, I'm telling you. If at the units place it's 0, then the number is divisible by 10. Now, the divisibility rule of 11. In this, what I have to do is, I have to check, the alternate numbers. I'll add the alternate numbers and then I'll subtract the alternate number, the sum of the alternate numbers. If that sum is 0 or it is, divisible by 11, then I'll say the number is divisible by 11. You'll understand it better if I illustrate it with an example. Suppose the number is 94195 If this is the number, what I'll do, I'll add 9 plus 1 and then plus 5. And then I'll add this 4 plus 9 and 2. So 9 plus 1 is 10. 10 plus 5 is 15. This is the sum of this group. What is the sum of the other? 9 plus 4 is 13. 13 plus 2 is 15. 15 minus 15. If both the sums are equal or if the difference is 0, then I will say that yes, the number is divisible by 11. So there are two things which we have to see. If the difference is either 0 or it is a multiple of 11, or in other words, if that sum is divisible by 11, then I will say that the entire number is divisible by 11. I'll repeat it again. What we are doing over here is, see this number 941952. We just have to group them in alternate numbers. So 9 plus 1 plus 5. So this becomes one group. Another group is 4 plus 9 plus 2. I have added both of them, both the groups. For the first it is 15. For the second also it is 15. Then I have subtracted. What if the difference is 0, then also the number is divisible by 11, or this difference is, is divisible by 11, then also the entire number is divisible by 11. As I promised you that I'll tell you the logic with which you can also find the divisibility rules of many of the bigger numbers also. So I'll tell you that logic. If there is a number n and it is divisible by a number p, and the same number is also divisible by q in such a way that p and q are co-primes. P and q are co-primes. That is, they don't have any common factor between them except 1. Then this number n will also be divisible by p into q. Let's understand this with an example. Suppose, let's take the divisibility rule of 12. With this, we'll understand that logic also, and we'll also understand the divisibility rule of 12. Suppose there is a number n. If it gets divided by 3, that is, it is completely divisible by 3, and it is also divisible by 4. And we know that 3 and 4, they don't have any common factor between them except 1. So they are co-primes. 3 and 4 are co-primes. Then we can say that particular number is also divisible by 3 into 4. That is, it will be divisible by 12. They are not equal. Okay. So this is the divisibility rule of 12. In this, we just have to check whether the number is divisible by 3 and 4, both. Then it will be divisible by 12. Simple. Now, divisibility rule of 14. Here also, we will apply the same logic. We have to find the two factors for 14 in such a way that the two factors are co-primes to each other. 7 2s are 14. Then the divisibility rule of 14 becomes like this. If the number is divisible by 7 and also by 2, then that number will be divisible by 14. Simple. This is the logic behind the divisibility rule of 14. Now, for 15 also you have to find that two numbers, when they are multiplied together, they give us this number 15 in such a way that they are co-primes. So for 15, 3 5s are 15. Both of them are co-prime. So therefore, if a number is divisible by 3 and also by 5, then we'll say that the number is divisible by 15. I want you to do it on your own, Just check with other numbers, multiples of 15, and check the rule. Because math is learned by practice, by when it actually goes, under your hand. So I hope you will practice all these things on your own. Try out with other numbers and see whether this rule is working for you or not. Divisibility rule of 16. This will work the similar way in which the divisibility rule of 2, 4 and 8 were working. If you remember, for 2 we were checking the units place. For 4 we were checking tens and the units place. For 8 we were checking hundreds, tens and units place. Every time, if you see, the number is getting doubled and the places we were checking were also adding up by 1. So if till 8 you were checking 3, so for 16, how many will we'll check? 4. For 32, how many will check? 5. Similarly, we just have to, keep on checking. The same rule will apply for all the numbers which are, just the double of the 2. 2 to the 4, 4 to the 8, 6 to the 32, 32 to 64, 64 to the 128 and so on. We just every time whenever it is getting doubled, we have to increase the place. So for 16, we have to check the last 4. 1, 2, 3 and 4. That is the units place, the tens place, the hundreds place and the thousands place, irrespective of what the numbers lies over here. So here I have this number 5, 1, 7, 9, 2. I have already done my homework and I have already checked that this 1792 is already divisible by 16. So I will say that this number 51,792 will also be divisible by 16. Simple. I can keep on adding no matter how many numbers over here. It will not matter. Still, I just have to check for these last 4 digits to check for the divisibility of 16. So now, can you guess the divisibility rule of 18? So now, when the number is 18, I can form this number by various factors, right? 2 9s are 18 or 6 3s are 18. Both are true. So which group I will use to check the divisibility of 18? I will use this group. Why? Because these together, they are co-primes. They don't have any factor in common between them. Whereas 6 and 3, the common factor between them is 3 itself. So this will not work for the divisibility of 18. But this will work because the 2 are the co-primes of each other. So if the number is divisible by 2 and also by 9, we can say that yes, the number is divisible by 18 also. Similarly, if we'll check the divisibility of 20, again, 20 can be formed like 2 and 10. This is also 20. Or it will also be like 5 and 4. So which group you want to choose to check the divisibility? 2 or 10 or 5 or 4? Yes, we will choose 5 and 4 because they are co-primes. Whereas they are not co-primes. They have a common factor 2. So we can say if a number is divisible by 5 and also by 4, then that number will also be divisible by 20. Now let's take another number also. That is 22. 11 2s are 22. Simple, both of them are co-prime and therefore I can say that if a number is divisible by 11 and also by 2, then that number is divisible by 22. Simple. Another number, 24. Then again, this can be formed by as 6 4s are 24, 3 8s are 24, 12 2s are 24. Various combinations. With various combinations, I can reach up to here 24. So for divisibility, which combination I will use? I will use the combination of co-primes. So which are co-primes? They have common factor between them. That is 2. 6 is also getting divided by 2 and 4 is also. So they have a common factor. But 3 and 8, they don't have any common factor except 1. So they are co-primes. I will choose this as the divisibility rule of 24. So I can say that if a number is divided by 3 and also by 8, then that entire number will also be divided by 24. Now shall we take a bigger number that is made up of not 2 but 3 prime factors, 3 co-primes. Let's take this number 120. Let's try. So I can say 12 into 10. They are not co-primes. Can I say 3 4s are 12 and then 5 into 2. 10 I have represented like 5 2s are and 12 like 3 4s are. But still they are not co-prime, 2 and 4. So what I'll do is, I'll say 3 into 5, 3 15, 15 into 8. That will be
120.
If you see, there are all co-primes. So if a number is such that it is divisible by 3, 5 and 8, I can say that yes, my number is also divisible by 120. So I hope the divisibility rules are clear. They are very simple but very important, for us to know and to apply them whenever we are solving the questions, especially of factors and multiples. They should be, crystal clear. Let's meet in our next video with factors and multiples, HCF and LCM. We'll continue with the same chapter. Thank you so much for watching.